The objective of this project is to compare and contrast the average velocity and average acceleration of a futsal ball being kicked versus the average velocity and average acceleration of a basketball being kicked.
The hypothesis is that the futsal ball will have a higher average velocity and a higher average acceleration than that of the basketball. This is because futsal balls are specifically designed to be kicked, whilst basketballs are not.
Procedure. Step 1. Lay a meter stick on the ground. Have a group member lay down a ball next to the meter stick. This will be done with 2 different balls. Have the group member stand directly beside the stick, facing a wall. This should be done standing 6 to 7 meters away from the wall. Step 2. Position the camera tripod approximately 12 to 15 meters away from the meter stick so that the camera is perpendicular to the meter stick. Determine camera frame for graph building and any additional footage desired.
Step 3. When all group members are ready, begin recording with a group member on an iPad using the Vernier Video Physics app. Record a group member kicking the basketball. Make sure to record at least 3 to 5 takes in order to achieve the best possible footage. Repeat this step with a futsal ball. Step 4. Once finished recording, find the best take recorded for each ball. Use the Vernier Video Physics app to graph the motion of each ball.
Step 5. Compare and analyze the 3 different graphs from each ball: position versus time, velocity versus time, and acceleration versus time. Record all observations and conclude whether the hypothesis was correct.
The 2 acceleration versus time graphs have some significant differences between them. At any given time in the acceleration versus time graph for the basketball, the instantaneous acceleration ranged from over 17.3 meters per second squared to negative 24.7 meters per second squared. This sporadic range could have been the case due to a number of factors. For example, wind resistance, friction, and the surface of the basketball. The average acceleration for the entire time the basketball was in motion was negative 4.597 meters per second squared. This was calculated using the formula V2 minus V1 divided by T2 minus T1. The futsal ball, however, acted differently. At any given time on its acceleration versus time graph, the ball's instantaneous acceleration ranged from 11.5 meters per second squared to 2.6 meters per second squared. The acceleration was never negative with the futsal ball. The acceleration versus time graph was also far smoother as the acceleration gradually decreases overall. There are some points where the acceleration suddenly spikes, such as at about t equals 2.45 seconds, but it's decreasing for the most part. This is because the futsal ball was designed to be kicked and by extension was designed to roll more smoothly on the ground than the basketball. The average acceleration for the entire time the futsal ball was in motion was negative 6.01 meters per second squared. This was also calculated using the formula V2 minus V1 divided by T2 minus T1.
When comparing the 2 motion graphs, it can be observed from the graphs that the basketball seems to have slightly less uniform motion than the futsal ball. This can be expected as futsal balls are meant to be kicked, as where basketballs are not. Notably, the basketball took slightly more time to hit the target. This can be attributed to the increase of weight of the object. The collection of accurate data was achieved by using the same reference point for both the basketball and the futsal ball. The displacement of the balls at every instant were always the length that they were from the reference point, which was the beginning of the meter stick.
The velocity of the basketball was found to decrease very quickly, until t equals 2.3 seconds, where the basketball stays at around the same velocity until the basketball hits its target. At any point in time on the graph, the instantaneous velocity of the basketball varies from 8.47 meters per second to 3.25 meters per second. The velocity time graph of the futsal ball was smooth, and it had an overall gradual decrease in velocity over time. The futsal ball did not slow down to a certain speed, in case it slowed down at a slower rate than the basketball, but was almost constantly decelerating until it hit its target. At any point in time on the graph, the instantaneous velocity of the futsal ball ranges from 10.81 meters per second to 4.94 meters per second. The 2 velocity time graphs differ from each other quite a bit. The instantaneous velocity of the futsal ball at any time compared to the basketball was always higher. This can be attributed to the fact that the futsal ball was designed to be kicked on the ground, while the basketball was not. Because of this, the basketball slowed down much faster over time than the futsal ball. The graph of the futsal ball slowed down at a more gradual rate than the basketball. However, it still took less time to hit its target than the basketball. Therefore, the graph of the futsal ball was also far smoother. The average velocity for the basketball is 5.048 meters per second, compared to the average velocity of the futsal ball, which is 8.439 meters per second. This was calculated by using the formula P2 minus P1 divided by T2 minus T1.
In conclusion, it was shown that the hypothesis stated was correct. It was shown that the futsal ball had both a greater average velocity and a greater average acceleration than the basketball. It was determined that the average velocity for the basketball was 5.048 meters per second compared to the average velocity of 8.439 meters per second for the futsal ball. It was also determined that the average acceleration for the entire time the basketball was in motion was negative 4.597 meters per second squared, compared to the average acceleration of the futsal ball for the same time at negative 6.01 meters per second squared.
There are many factors that could have caused errors. Sources of errors could be 1. Wind resistance for or against either ball during the time the data was collected. 2. The initial force of the kick for one ball could have been greater than the other. 3. The kick's direction may have varied. Because the surface of the ball that it was kicked upon isn't smooth, this could have changed the velocity or acceleration of either ball. 4. Friction was not accounted for. And finally 5. The reference points for the ball from which the kick was delivered may have varied slightly.